Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on conditional probability. So by the end of this video, I hope you can understand and apply the conditional probability formula. So what are we talking about with conditional probability? Well, you know what a condition means. It's like something that has to happen. So for example, if I say you will only get an A in maths if you do your homework, doing your homework is a condition for you getting an A, something that needs to happen. So whether or not you agree with that, conditional statements are important in probability. Sometimes, if an event happens, it changes the probability that another event will happen. So for example, think of your favorite sports team and the probability they win. If the best player doesn't play for your team, that's a condition, and that would change the probability. It would make it less likely that your team would win. So that's what we're looking at here, the probability that an event happens given that something else has happened. So let's try and understand this better using an example. So let's say I roll a normal six-sided die. What is the probability I roll a multiple of 3 given that the number I roll is greater than 2? So just for simplicity, we'll let A be the event that I roll a multiple of 3 and B the event I roll a number greater than 2. So this is a conditional statement because there's a condition here that the number I roll is greater than 2. So we're going to look at, if I know the number I roll is greater than 2, does that affect the probability that the number is a multiple of 3? So the probability, if I just roll a normal six-sided die, the probability that the number's a multiple of 3 is 2 over 6. There are two ways I can roll a multiple of 3. I can get a 3 or a 6. So 2 over 6 or 1/3. So the probability I roll a number greater than 2, note 2 is not greater than 2. There are 4 ways this can happen. I can get a 3, 4, 5, or 6 out of 6 outcomes in total. So what I'm looking for in this question, though, is not the probability of A or the probability of B. I'm looking for the probability of A given that B has happened. And we use this line here. This says probability of A given B. What is the probability A happens if I know that B has happened? So if I know that B has happened, if I know that I have rolled a number greater than 2, then there are 4 options, 3, 4, 5, 6. Of those 4 options, there are 2 that are multiples of 3, this one and this one. So the probability of A given B, there are 2 ways that I can roll a multiple of 3, but there are only 4 choices in total. So 2 over 4 is, of course, a half. So we can see here, if I roll a normal die, the probability I get a multiple of 3 is only 1/3. But if I tell you that the number's greater than 2, the probability increases to a half. Knowing that this happened, that the number was greater than 2, increased the chances that this would happen. So there's actually a way that I can calculate this using a formula. The probability of A given B is the probability they both happen, probability of A and B, remember that little N intersection means and, over the probability of B. So just be careful with the formula here. Whichever one is listed second, that is the one that goes on the bottom. So if I use this formula, I would have got the same answer up here. So the probability of A and B in this case, the probability I roll a multiple of 3 and a number greater than 2, well, that is still 2 over 6. The probability if I roll a die that I get a multiple of 3 and greater than 2, I can have that happen 2 ways out of 6 in total. The probability of B, as I figured out there, was 4 over 6. So 2 over 6 divided by 4 over 6, you can use your calculator, I get a half. I get exactly the same answer. So this is the formula that you need to know. Sometimes knowing an event happens affects the chances that something else will happen. So let's look at another example. So this time I'm telling you what probability of A given B is and what probability of A, probability of B are. we're going to use that to calculate probability of B given A and probability of A or B. Now, to calculate both of these, what we need to know is probability of A and B. So we can get that from the formula. So the formula I gave in the previous slide, we said probability of A given B is equal to probability of A and B, and whichever one's listed second goes on the bottom. So because B was second, it goes on the bottom. So I can just substitute the values from up here into this equation. So I have probability of A given B is 0.5. That's equal to probability of A and B all divided by 0.4. So the probability of A and B is just 0.4 times 0.5, just rearranging that equation. And that gives us 0.2. So now that I know what probability of A and B is, I can calculate these two simply. So to calculate the probability of B given A, now note, B given A is not the same as A given B. The formula is almost the same. We still have an A and B on top, but this time probability of A goes on the bottom. Whatever's listed second goes on the bottom. So this will simply be probability of A and B, I figured out. Probability of A was 0.6. And if you put that on your calculator, you get 0.3 recurring or a third. So note, probability of B given A, which was a third, is not necessarily equal to probability of A given B. So how I would calculate this, well, this is what we learned in previous lesson. That would just be the probability of A plus the probability of B minus the probability of both. So probability of A we know is 0.6. Probability of B is 0.4. The probability of both I figured out was 0.2. So just adding those together, you get 0.8. So there is a very clear link between probability of A or B, A and B, and A given B or B given A. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.